In last session, we discussed about couple of SQL Server related stuff and couple of topics on SQL Server, like what is the logical query execution way of a select statement, and also joins. In this session, we're going to discuss about couple of things like unions, first thing, and how to create backup tables using queries, and we're going to discuss about subqueries, which is very important concept. So this subqueries concept is also present in MDX, but we have not covered it as it is not of high priority. So we can spend one session on that once you become familiar with subqueries. So to start with, let me go to the database. First thing is creating a backup table. How to create a backup table, like creating the backup and loading the data. So let's say I'll take a product table, select star from dim product. So this will this is having 606 records. You can see it, the record count, and how to in general how people take the backup and loads the same data into the new table. So what they will do is, first they will go to the tables and they will take the structure, or they will take the syntax of the create statement. You can see script table as create to a new window. That means it will provide you the create script to the new window, and they will name it as underscore test1. They cannot have the same name, right? The same name, already a table exists, and they will execute it. Now, yeah, the problem with the primary keys and the primary key names and so on. So the primary key names already exist, so we have to give a different name. I'll give it as underscore test1. And what is the other one? This is changed, and this needs to be changed, the foreign key name. The name of the foreign key is fk underscore something underscore blah blah blah. So I changed all these things, executed. There is already an object ak something in the product. Let me change this one to ak underscore. It is here. I'll name it as underscore test1. So what I've done is I changed the table name, and the primary key, foreign key, and all those stuff used in the same table, the names will be repeated, and hence it is throwing this error. And now it is having one more. Oh shit, it is having a lot of primary keys, man. What I will do is I will delete this primary key stuff. I don't want to maintain anything here. This is the easiest way. So what I'm doing is I'm just executing the table. Oops, already product table is created. Okay. Now, first what they will do is they will take the script and they will create the table, and as part of the next step, they will use insert into table name dim product underscore test1. I'm inserting data into this table. We already discussed about these queries. Just I'm refreshing. I'm just refreshing the concept. That's it. Select star from dim product. So the same column should be there. Oops, there is an identity column and we cannot pass the value. I have not seen that. This is not the best table to show this example. Let me take some other table. This is really showing me hell. So let me go to MSBI database where I have a couple of tables. Select star from employee underscore info is one table name. If I execute this, I have 6 records. So now let's see. Let's follow the same steps. How people take the backup of an existing table. The first step what they will do is they will take the table structure, that is create to a new window, script table as create to new window, and I cannot give the same name. Why? Because object already exists, error will come. I've given info1. If I execute this, the syntax, the table is created, and the next step is insert into newly created table, that is employee underscore info 1. Select the data from the main table, employee info. So what I'm doing in this statement is get the data from employee info table and insert into the newly created table, that is employee underscore info, and you can see 6 records affected. So let me execute let me get the data from both the tables now. Select star from employee info and employee info 1, the one I created to maintain a backup. So if you see here, both are having the same. So the steps I followed is first take the structure of the table, execute it, and then use the statement insert into so and so. There is one more way to do the same, that is the combination of select plus insert. Like select star, here we will have insert part into new table name, employee underscore info 2. This is the name I want to give, from employee underscore info. If you see this query is the combination of select statement as well as insert statement. Insert this part into employee info 2 is the insert part. If you see that insert into employee info 1 byte, that is this insert into employee info 2. This is in part of insert statement. And if you remove this, let me cut this, you can see select star from employee info. This is select statement. By using the combination of insert statement and select statement, you can create a backup. There is no table called employee info 2 at this point of time, right? So if I execute this, 6 rows affected. Let's see whether it created or not. Employee info 2, I executed all the 3. You can see the third table is also created with the same data. What this query will do is, the query first gets all the data from the table and create a similar table, with a new table name that is given here, and loads the data. So it will do 3 jobs. Creates a table with the given name, and the structure is by getting the structure of this particular one, and then loads the data from the table, main table I can say. So it will do these two jobs, one single query. Sometimes people will ask for, man, I just need structure, I don't want data in it. I just want structure of the table, let's say employee info table or something else. So how you can do that? So to do the same, you can use the same query, but having some where condition which will filter the data, right? Where 1 is equal to 2. Obviously 1 is not equal to 2. At any point of time 1 is not equal to 2. So it won't retrieve any record, but oops, already 2 exists. So let me go for 3. It won't get any records, but it will execute the first step, that is creating the table with the given name. So if you see, the structure will be created for this table, but the data will not be loaded. You can see select star from employee info 3 is having blank records. So why I am explaining all this stuff? Why you need to take the backup? Backup of a table. Most of the cases in software companies, in real-time projects, whenever you are working for any software project, you need to take the backups. Why? Because there will be an important table, very, very important table. Let's say in this case, dim product is a very important table. If you find an issue in the data, you cannot blindly change it. Why? Because it will have impact somewhere else. Some other place, people might be using the same data. So you cannot blindly change it. And if your change is creating more problem to the project, then you will be fired from the company. It will be a very serious issue. Not fired, it will be a very serious issue. So to be on safe side, what people do is they will take the backup. If they want to modify dim product table, let's assume. So they will take the backup and they will name it as dim product underscore the date, the current date. So on this particular date, I have taken a backup, and this table is having the data. So next day, if any problem comes because of the change you have done to the table, you can easily restore the data from one table to, the backup table to the new one, or the main one. So that is why taking backup is very important, and that's why I explained this stuff, how to take the backup of a table. Now I have three tables, three or four, I think three, which is having data. You can see these three are having the same data. In last session we discussed about joins, and it's good to spend a couple of minutes at least on unions. What is union? You know, the join will join two tables. The union also join two tables. But the difference between join and union is join joins two tables column wise. So the columns will be attached. To demonstrate the same, if I take the pen, let's say this is your first table, which is having some 3 columns, and this is your second table. Sorry, I have 4 columns in the first one and 3 columns in the second one. So in this case, if you use join, it joins column wise. So it will become like this, the end table, which will have 1, 2, 3, 4, 5, 6 and 7 columns. So it is joining column wise. This is join. So to do the join, what is the criteria? There will be at least one matching column. Right? The data should on one column in both the tables should be matching at least. So this is the criteria for joins. Now let's see union. I have a table 1 with 3 columns. I have a table with 2 columns. If I, or 3 columns, let's say 3 columns. If I union these two, the output will be like this. You will have 3 columns, and up to here, this is the first table data and the second table data. This data joins row wise, but here the data join, the two tables joins column wise. That's the major difference between union and the join. In union, the first and foremost criteria is, while writing a select statement, you have to make sure the first select statement columns, let's say I have written select statement on this table, it has 3 columns, and the second select statement columns are same. The number of columns should be the same. That's the first and foremost criteria you have to make sure. Next thing is, the first column in the first select statement and the second column in the first column in the second statement should have the same data type. This data type and this data type should be matching. The third column data type and the third column data type here should be matching. These two are very important factors that you have to keep in mind while writing unions. Now let's see how to write unions. So I'm taking all these tables. So first what I'm doing here is, there are two types of unions. One is union and one is another one is union all. Let's start with union all first. So this is the first select statement. You have to write union all, the second select statement. That's it. You don't need to add any condition like that. The only check you have to make sure is the number of columns should be same in the first select statement, that is this one, and the union second statement, the second statement. So this one. And these two tables are having same number of columns, that is city, country, employee ID, name and state, as you can see on the screen. And for this one also, you will have the same. Why? Because this is the backup created from the same table. So you can see it here. When I keep the mouse on asterisk, you can see the columns that are present. If I execute this, it will union these two tables, and you can see the same number of columns are written, but the rows are concatenated. And I can union n number of tables. Union all. This is done. All the 3 table data is joined row wise. Now let's see what is, this is union all. Union all, it will fetch the duplicate data also. You can see this record is duplicated here and also here, same data present in. So the union all brings the duplicated data, whereas union will not bring the duplicate records. If I make it as union, you can see only one set is coming. Why? Because the duplicates are removed. And it is not mandatory that you have to go for either union or union all for the complete query. If you see this query, for the first two statements, I am going for union all, and the second one and the third one I am going for union. So the first two statements will fetch. Oops, sorry. The problem here is first these two will be executed, right? And the record set will have 12 records. The first table records and the second table records. And then this guy will union with this. So what will happen? It will have only distinct records, and hence it is not coming. Now let me show you something. What will happen if I give all union all for the second query and the third query? You can see you are getting duplicate data, which means first this query will be executed and it will get only 6 records, and then it will union with the third query, which will fetch 3 more records, total 6 more records, total 12 records. So this is about union and union all. What will happen if I remove couple of columns from here? I'm giving only employee ID, comma, name, comma, city. Let's say I don't have all the 5 columns in my table. Assume that. I can't create a new table now. So I'm saying let's assume. Or I can create a new table. It's not a big deal. What I'm going to do here is select. I'll go for one more table, table 4. And here I'm going to give ID, employee ID, comma, name, comma, city. I'm getting only these 3 columns and pushing it to the employee 4 table, right? And now I will add it in the union part. Star union all select star from the newly created table with only 3 columns. You can see the same when I execute this. Now if I execute the complete query, it will throw error saying that while going for union, intersect or except operator, the expressions columns should be same in count. This guy is having problem now. This guy is having only 3 columns. How to overcome this? I can have 2 blank columns as state. This is the one which is not present, and blank as country. This is one workaround. So then now the number of columns should be matching, and hence it is getting the data, but the missing columns is getting filled with blank value as specified in the select statement. So this is how you can go for unions and unioning 2 tables or 2 select statements with not exact match of columns in count wise, if you see. So you can expect a question on the differences between union and join. Just to confuse you guys, people will ask sometimes. So better keep in mind about union, and it's a good option. You may need it. So it's always good to know, or good to have an idea on union and union all, and how to union 2 tables or 2 select statements. Next, we are gonna look at some important concepts in SQL Server, that is subqueries. Subqueries. What is meant by subquery? Subquery is nothing but a query inside a query. So generally you will have one select statement, right? If you have one more select statement inside a select statement, then that will become a subquery, or we can call it as nesting of queries. Let's say like this: select star from table name where some condition is equal to, instead of providing some value, you can have a select statement here, blah 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 blah, table name. So this is the query which is inside the main query. The outside, this query is called outermost query, and this query is called inner query. This is inner query and this is outer query. So when 2 queries are nested, then we call the inner one as a subquery. This is the subquery for this main query. So what is the advantage of having this? Why we need these subqueries? Sometimes while checking the condition or while filtering the data, you may not able to hard code some value. If you want to check based on some dynamic values, then you need these subqueries. The best example is While working on SSAs, you will be getting errors saying that the key column is not present. The attribute key is not available, so it is creating some problem, blah, blah, blah. Something is there. Let me go for it once again. Okay. I'll go for one example here. Let me go to AdventureWorks database and let me take a new query window. Select star from fact internet sales. This is the data I'm having, and I'm going for select star from dim product. So to demonstrate the same, to demonstrate these subqueries, what I'm going to do is I'm going to remove couple of records from product table. So what I'm going to delete is delete from dim product where product key less than 7. That means all the values that are less than 7 will be deleted. But I cannot go with this option straight, or I cannot straight away delete this. Why? Because I need this data for my future sessions or future reference, right? I may need this data. So what I can do? I can create a backup for this and store the data, and I can use it. I can restore it whenever I need the full data. So taking the backup, select star into. This is how we take in real time projects. Dim product underscore, what is today's date? 14/02/2013 from dim product. So if I execute this, you can see I have a backup table ready now. I can play with the dim product table. This table is ready. Whenever I want, I can restore the data from this table to the main dim product table. See, this table is ready for me, which acts as a backup. So let me delete this stuff. Now I can delete these records. 6 records deleted, less than 7 I have given the condition, and you can see those 6 records are not coming. So if you create a SSAS project with these two tables, it will throw error saying that there is a master key, there is an ID 1 in the fact table which is not present in the master table, and we call these records as orphan records. So now I have to check what are all the records that are missing. How can we do that? Using subqueries. Subqueries is the best option here. You can do the same job using joins, but we prefer to go with subqueries, and performance wise it's almost the same. It won't have much difference. Now let's see how to write a subquery. Select star. Before going for the first example, let's discuss about the type of subqueries we have. We have two types of subqueries. One is self-contained. Second one is correlated. So we have two types of subqueries. One is self-contained and another one is correlated. What is meant by self-contained and what is meant by correlated? It's very difficult to explain. It's better if I explain with an example. So let me take an example for the self-contained. And each self-contained and correlated is subdivided into two parts. One is scalar. Another one is multi-value. So we are gonna see all these stuff or examples for everything in this session. First, let me go for self-contained scalar. Okay. When the inner query returns only single value, then we call it as scalar. So as I showed you here, the syntax, if this inner query returns only single value, then we call it as scalar subquery. So whenever you are using equal to, there should be only one value returning. If it returns more than one value, then equal to will not work, right? Obviously, whenever it is equal to, only single value should be given. When it is returning multi-values, what you have to provide? You have to provide in condition normally. Hope you still remember the concepts, basic concepts of SQL Server. So equal to means single value should be fetched for this from this inner query, and we call it as scalar. And if it is in operator, then it can be more. I'll give you an example where color is equal to will give single value, right? Where color in we can give multi values like black, blue, and so on. So this is the difference. This guy is accepting two values. Why? Because the operator is in, and if we use in here, if the inner query is fetching more than one record, we call it as multi-value, whereas if it is returning only one record with the operator equal to, then we call it as scalar subquery. Let's see example for everything. Select star from fact internet sales. I want to get the fact internet sales where product key is equal to 7, let's say, where product key is equal to, here instead of hard coding the value, okay, my intention, my requirement is to get the maximum product value, whatever the product value maximum that is present, I want that value. If you see, the maximum value is 606, but this will be keep on changing. If tomorrow some other guy adds a product, so a new value will be coming to the table. So in short, my requirement is what is the latest or the most recently added product and its sales. I can get the sales information from this table where product key is equal to, what I have to do. When I use is equal to, the inner query should return only one value, and we call it as scalar subquery. So if I use select product key from dim product table, this will throw error saying that the subquery more than one value. Subquery return more than one value, but I'm using the operator equal to, right? See, it is clearly given in the error. You can see this is not permitted when the subquery follows equal to, not equal to, less than or equal to, greater than or equal to. Whenever you are using these operators, the inner query, that is the subquery, should return only one value, and we call it as scalar subqueries. So what is my requirement? I want to get the maximum product. That is, what is the maximum value of this product key, and for that, if there is any sales, I want to return. Now this inner query will return only one value, that is the maximum value, that is 606 in this case, and the outer query will generate all the records in the fact internet sales with the product key 606. You can see the product key it is taking is 606, and if you give greater than, then it will get the maximum value, that is 606, and if it will try to get if there is any fact internet sales records where product key greater than 606, which is not available, and it returns 0. If you give less than, it will return everything except 606. You can see you will not find 606 here. Why? Because I have given less than. If I give less than or equal to, you will get even 606 in the result set. And in the same way, greater than or equal to. So for all these operators, you can go for only the subquery should return only one value, and we call it as scalar subquery. And these kind of subqueries, what you are seeing here, are called as self-contained subqueries. What is meant by self-contained? The inner query, I mean this query, is not dependent on the outer query. It is not dependent on the outer query. It is just passing value to the outer query. It is not taking the help from the inner query. If you see here, this guy is passing value to the outer query, but it is not taking any help from the outer query. So these kind of things is called as self-contained subqueries. This is an example for self-contained scalar value subquery. Now let's see self-contained multi-valued example for multi-value. It will be the same, right? The operator will be in. If you give in, you can get all the product keys if you want. Get all the fact internet sales where product key, select product key, and the product key in this list. So what it will return? It will return only the fact internet sales which has product key in the master table. If I provide not in, what it will return? It will return the orphan records. Orphan records. Okay. It is not returning any records. Let me check why it is. I think there was no sales for the products 1, 2, 3, 4, 5, 6 which we deleted. Or else let me delete one more record, that is 606. The product ID 606 is also deleted and it has foreign key referential integrity, so we cannot delete it. So keep in mind we have two types of subqueries. One is scalar and multi-valued, and self-contained and correlated, and each one will have two subparts or subtypes. One is scalar and multi-valued. Scalar means the inner subquery will return only single value, whereas multi-valued means it can return more than one value. And the outer query will check in that particular set of records that is returning by the inner query. And it also depends on if the number of records that is being fetched is more than one, then you cannot use equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to. So you have to use operator either in or not in, or we have one more thing, greater than any. So this is one more thing which you can use. So what this greater than any will do is, this is returning so many records, right? This is returning so many records. It will check for the product which is greater than any one of these products. So in this case 346 is greater than any one of this product. True. 336 is greater than any one of the product key. We have product key starting from 7. So it will check and retrieve any greater than, if it is greater than any one of the records. So that is how you can use greater than any. And there is one more keyword, that is greater than all. So this returns the data for the sales where it is greater than all the products, all the product keys that is being fetched by this guy. So if this guy is fetching from 7 to 606, sorry, 541, we have only 541, should be more, right? It is not in order, it seems. Yeah, it is not in order. Let me check. Select product key from dim product. Yeah, it is not in order here. Let me order it. Order by product key. Let's see now. We have starting one is 7 and ending one is 606. But here, if you give greater than all, it will go and check. It will get all the product keys from here, and it will check the product, all the product keys with all the product keys in the that is being fetched from by the inner query. So it will fetch only when this product key, we have product keys from 1 to 606 in this table also. This should be greater than all of this. It is not a possible scenario, right? So if you give equal to greater than all of this, then you will get the record for the last one. Why? Because this is greater than all the records or equal to at least the maximum, all the product keys that is present in the inner query. So this is pretty tricky. You just have to try it at home again and again to get good grip on this, but it is very useful feature. This is mostly used while checking the dates, greater than or any, greater than one date or greater than many dates. In such kind of scenarios you use these things. Okay. This is about scalar, self-contained, and multi-valued self-contained subqueries. Now let's see correlated subqueries. What is meant by correlated subquery? When the outer subquery is getting value from inner one, and inner subquery is getting value from outer one. So that means the inner query is dependent on outer query. So if you have such kind of queries, then we call it as correlated. Inner one and outer one is correlated. So that is called correlated subqueries. And let's see an example here for correlated subqueries. Now let's see an example for correlated subqueries. Okay. Let's say I want to get some select star from fact internet sales. Sorry. fact internet sales, I'll alias it. I can do it only by using aliases. I'm giving alias name A, where product key in, I'm writing select top 1 or top 10 product keys from bin product. Okay, let's see what it will return. The first in the what the inner query will return. The inner query is returning 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. And if I execute this query, the whole query, you may not get data. Why? Because the keys that are present, the keys that are fetching by using the top keyword here is not present in the fact internet sales. So what will be the best option? If I can get the keys that are present in this one, and if I get the top sales for the top 10 keys. So this is the top 10 keys which is present in the dim product table, and these keys are not present in the fact internet sales. If I can join these two tables, or I can pass value from here to here, so that it will check, okay, only the keys that are present in the fact internet sales, get top 10 list from that. So that will be helpful. The data will be retrieved. So how we can do is, I'm giving alias where b dot product key is equal to a dot product key. So if you observe the query here, it looks very similar to the normal self-contained query, but the only difference is I'm passing value from the outside table. I'm passing value to check whether to pull the records from the inside query only when it has the same keys as the outside table. So the product key from here I'm passing to this inside table. So this is what I said, correlated subquery, which means both the queries are related. The inner query will get value from the outer query, and the outer query will get value from the inner query. So to generate the inner query result set, it is taking the help of product key and from the outside table, and to check the outside keys, it is taking the help of inside queries output. If I execute this now, it will get data. Why? Because it will get the products which are present in outside table. So that is why it is fetching the data. In the earlier case, when I did not use the correlated subquery, it was not retrieving the data. The only reason is that the keys that are being pulled by the inner query is not present in the outside table. So this is called correlated subqueries. You can have one record, that is, which means a scalar. If it is 1, you can go for equal to, right? So this one will become scalar correlated subquery. And if you go for, what I can say, more than one records, then you have to go for in statement. This will be multi-value subqueries. So this is how you can define correlated subqueries. So what extra part you are going to do as part of this correlated subqueries is passing the value from outside table to inside table. Now let's see where all we can provide these subqueries. You can provide these subqueries in many places, like in select statement, in where class, in joins. There are many places where you can provide these subqueries. Let's see a couple of examples. Select product key. Okay, let me go for select star from product, dim product, sorry. This table is having so many records. What my intention is, I want to get product key, comma, average of product key. I want to get the average of product key with some condition, or I can, what I'm saying is I can inject a subquery here also. I'm injecting a subquery, select average of, let's say fact sales amount from fact internet sales. Is it correct? the spelling. This spelling is correct. Select average of sales amount. It is not a from, it is from. From fact internet sales. So if you see this query, this is a subquery for which I am using average of sales amount from the fact internet sales. Sorry, new page was opened by mistake. So let me close this guy. So this is the subquery I have given at column level. And if I execute this, you can see it is getting the total sales amount, average of sales amount, and it is returning as part of the result set. So this is one area where you can provide the subquery. There is one more area where you can provide subquery. We discussed about where condition where you can provide the where queries, and couple of other areas are there, like select star from let's say dim product, inner join. Generally, you will give fact table, right? Fact table name, that is fact internet sales, and so on. Which means this guy will retrieve all the records from the fact internet sales and do inner join. Instead of specifying the table here, you can specify a subquery. Select product key. So start from fact internet sales. This is the fact internet sales information. And instead of going for all the columns, I can go like this. Distinct or group by. I'll go for group by. Product key, comma, sum of sales amount as sales. I have a non-aggregating column, so group by product key. If you see this query, this inner query in particularly, the one which I'm using after inner join, this guy will return product key wise sales amount, aggregated level. You can see only 158 records are returning. Earlier there are total, in total 60,000 records in the fact internet sales. Here I'm aggregating and I'm calling it as A, and I'm calling this as B. On A dot product key is equal to B dot product key. You can see these two will join now and retrieve the information. This is the product key and product table regarding information, and you can see at the end the sales and the product key from the subquery table which I used in the inner join. So this is the beauty of subqueries. You can use wherever you can provide expression, or you can provide a table. So you can use all the stuff in all the places, like in columns, in where condition, or in joining parts and so on. If you see here, if I provide English product name as one column and sales the another column, the report, the query output looks so beautiful. This is already pre-aggregated at one level. At product key level, it's already aggregated. So I'm fetching the data by joining with the dim product table. So instead of using fact internet sales, if my intention is to get only sales amount, sum of sales amount, then this is one best way to do the same. So this is how the subquery, these are the different types of subqueries: correlated and scalar and multi-valued, and self-contained and correlated. Correlated and self-contained will have these two types of subqueries, and this is how you can use, and very useful concept. I'm saying you will be using these subqueries again and again in your real-time projects. Now the next concept is table expressions. This is very similar to subqueries but not 100% same. Let's discuss about these table expressions in next session, which is very important. And there are few kind of requirements which you cannot achieve without taking the help of table expressions. So table expressions plays a major role to achieve some kind of requirement. So make sure that you will attend the next session. Thank you guys.